This problem is number 17 in the textbooks, and it's asking us to find the number of chairs, sofas, and tables to build, to manufacture, in order to maximize our profit. So let's set up our table. So we're going to set up the categories across the top row here. We'll have chairs, sofas, tables, and then our totals. And then along the side, as we always do, we're going to write our characteristics of these. So each one of these has carpentry, finishing, and upholstery, and a profit associated with it. So as we read through our problem, we see that each chair requires 6 hours of labor, 1 hour of finishing, 2 hours of upholstery, and produces $80 in profit. Each table uses 3 hours of labor, 1 hour of finishing, 5 hours of upholstery, and produces a profit of $70. And each table requires 8 hours of carpentry, 2 hours of finishing, no upholstery, and produces $120 in profit. Now we can also see that the number of hours available for labor is 768, but I'm going to write that as less than or equal to because we don't have to use all of that. There could be some leftover hours for carpentry. Less than or equal to 144 for finishing, and less than or equal to 216 for upholstery. So our linear program is right here. What we want to do is maximize this profit function, and our profit function is coming right from here, right? 80x plus 70y plus 120z. We get $80 for each table, $70 for each sofa, $80 for each chair, $70 for each sofa, and $120 for each table. That's what we want to find the maximum. But we have these constraints, right? We have the first constraint, the second, the third, and of course our non-negativity constraints. So we're going to use Zwig Media to solve this. So you can see I've entered our linear programming problem, maximize this function subject to these constraints. My mode is fraction. I have scrolled down to Tableau 4. Now this is 4 tableaus. You can imagine how much work this would be by pencil. We'll look at our active variables. X, Y, and Z are all active. S1, 2, and 3 are all inactive. These are all 0, so we can write our solution. So we're going to say here that the profit is maximum at this number right here. So profit is maximum at $10,640 when we build, and we can get that right here. X is the number of chairs, and that's going to be 98. So when we build 98 chairs, Y is the number of sofas, so we're going to build, there's our 1, 4 sofas, 4 sofas, and finally, here's our other active variable, Z is equal to 21, and 21 tables. Okay, now let's understand here, this is important, that this is the answer to our linear program. This is a word problem. It's asking us how many chairs, sofas, and tables should we build. The answer does not come like this. The answer should not be written X equals, Y equals, Z equals something, right? We're answering a question to somebody, and when you answer a question to somebody, you don't say, well, X equals, Y equals, Z equals. So this up here is the appropriate answer.